Hey, this is Todd Usher, and today we're talking about conditioned crawl spaces. Here we are inside one of our conditioned encapsulated crawl spaces. So this is a crawl space foundation underneath the house. And in most of our homes, we condition those crawl spaces. So we seal them from the outside. We don't insulate under the floor of the house. We insulate the walls of the foundation on the inside. And what that does is that basically creates a conditioned space underneath the house, somewhat similar to a mini basement. So we're conditioning this air underneath the house. You'll see that our heating and cooling ductwork is also contained in this space. So it's a very friendly environment for our ductwork because it's a conditioned space, humidity controlled, temperature controlled. And our ductwork does not like to be in spaces that are not humidity and temperature controlled. They tend to do things that we don't want them to do, like sweat and get mold and mildew growth on them. And the ductwork is essentially the lungs of our home. So we want to preserve good indoor air quality. And one of the ways we preserve indoor air quality is by encapsulating our crawl spaces. If any of you live on a home that's on a crawl space foundation that's vented to the outside, you probably know that the crawl space isn't a very nice place to be. It's musty. It's very humid. There's generally not a continuous barrier like you see on this crawl space across the floor, and that allows moisture from the ground to come up into the space. So in our conditioned crawl spaces, we do vent them during construction. So what you see right here is the vent through the foundation wall that has now been sealed. Once we start up the heating and cooling system in the house, we seal those foundation vents because we no longer need to let moisture out during construction. Above, we have our foundation wall insulation. This is foam board that's roughly 2 inches thick, so about an R13 on the exterior walls. Our vapor barrier goes up behind the foam board all the way, and then the foam board's sealed to the wall with an adhesive caulk. It's a very elastomeric, rubbery caulk, so it won't crumble or get brittle over time. Talked about the waterproofing to prevent the capillary action of moisture coming up through the masonry wall. And then we have our band, what we call the band between the crawl space foundation and the floor above. And we have to insulate that. So we use a fiberglass bat to insulate that band. The reason we use fiberglass bat instead of spray foam is because we're in a high termite area. And in a high termite zone, we want our termite inspector to be able to look behind this insulation to see if there are any termites. If there's spray foam in here, we can't just pull the insulation out, inspect for termites, and reinstall it. We also have exterior insulation on this house in the form of 1-inch foam board. So even behind this fiberglass bat insulation, there's 1 inch of exterior foam on the outside of this house that's also insulating this band. Another thing that we've learned over the years with our conditioned crawl spaces is we need to stop the capillary flow, which is the moisture wicking up from the ground and coming into the crawl space through the porous block or masonry foundation. So we spray this black waterproofing membrane on the top of the foundation and down a couple of block on the inside of the foundation to prevent any moisture that might wick up from the ground from coming into the crawl space through the porous masonry. Another view of our conditioned crawl space here looks perhaps a little chaotic, lots of pipes, ductwork, plumbing lines, refrigerant lines. The good thing, though, is all of this mechanical components are inside conditioned space, which is what we want. We want to preserve the indoor air quality in the house. And a conditioned encapsulated crawl space is one of the best ways we can do that in a mixed humid climate. So a few things to point out. The flex duct runs, you'll see they're running off of a trunk line here. This trunk line branches off, and the flex duct is very well supported. So all of the flex ducts run nice and flat and smooth. They're pulled to taut, and no dips or curves, sharp bends in the flex duct. That reduces the airflow. Right here is one of the supply ducts blowing air out into the crawl space, maintaining humidity and maintaining temperature in the crawl space. And then across the view there, you can see a pipe running under the membrane and then coming into a T and running up. That is our passive radon vent. We want to allow radon gas that's naturally occurring under the ground to go up through that pipe and out through the roof. We don't want it to come into the crawl space and get into the breathing air of the house. Radon is one of the leading causes of lung cancer, and this passive radon vent allows the radon to have a path of least resistance to go up and out of the home instead of into the occupied space. In this particular house, we're using an I-joist floor system, so you can see these I-joists run this direction through the house. They're supported by what's called an engineered beam or a laminated veneer lumber or LVL beam. That beam is supported by these piers, and the beam in turn supports the engineered floor system. We also glue the subfloor to the I-joist. If you look very closely, you can see the glue that oozes out between the top flange of the I-joist and the subfloor. In this particular case, our subfloor is OSB, which stands for Oriented Strand Board. And OSB subfloor is very common in this part of the country. Very strong and durable material that will last for many, many years. Why engineered floor systems? Well, they're a lot more stable than dimensional lumber or sawn lumber, and they result in a more quiet floor. So we don't get near as many floor squeaks out of an engineered floor system. And when we build conditioned crawl spaces, generally the I-joist floor system is what we use as our default. Very robust system, no squeaks in the floor, and we can make longer spans between these piers by using the engineered beams under the I-joist floor system. Now you will notice there's some green, what appears to be a green spray that's been applied to the engineered lumber and the beams in the vicinity of that pier. That's our termite pretreatment. And that's a non-toxic termite pretreatment. That is a borate-based treatment. Very toxic to termites, but only slightly more toxic to humans than seawater. What happens is if the termites come up from the ground and eat wood treated with that borate, they will die. So you'll see everywhere in all directions here where we have contact of wood with masonry that we've sprayed it with the boric acid, the borate treatment. And that comes 4 feet in all directions from where we contact foundation. This 4-inch gap in the insulation and the top of the foundation, this is what we call our termite inspection gap, and this allows our termite inspector to easily see if there are termite tunnels coming up from the ground behind the foam board trying to get into the wood. One other thing I want to show is our membrane. So this is a sample of the membrane that's lining this crawl space. Very tough material, and it's laminated white on one side, black on the other. You can't tear this material at all. It's so tough, and it's waterproof. So this is what's lining the crawl space floor here to prevent moisture and humidity from coming up into the house and allowing us to condition this crawl space. A couple of other elements here in this conditioned crawl space that can easily be seen. In addition to our duct work, we always have a foundation drain through the bottom of the lowest spot in the crawl space, and that's to allow a place for water to get out. So if we had a catastrophic plumbing failure, if we had a water line that burst and began to leak, We wouldn't want this crawl space to fill up like a swimming pool. We want it to have a way to get out. And this foundation drain has a one-way valve. So I'm going to take the top off here. And this gives us access to the backflow valve. So you see as I push my hand through here, that backflow valve allows water to go out, but will not allow water to backflow in to the crawl space. So we don't want it to be a place where water can come in, but we want it to be a place where water can go out. And as an extra measure, we use a water sensor. So this is a bulk water sensor that we put down here in the vicinity of the foundation drain, and that will alert us remotely. We monitor this for the homeowner, and it'll alert us remotely if there's ever water in this low area of the crawl space. This system also monitors humidity, so we're able to monitor temperature and humidity in the crawl space so that if ever there's a time where things get out of a safe range, we can alert the homeowner and come out and do an inspection. You will notice that there is some dirt and what looks like maybe some muddy residue. When they put this barrier in here and seal it to that low foundation drain, there's just no way to avoid getting that South Carolina red clay around the components. And there was probably some puddling water down here when they did this connection and made this seal. But it's very normal, nothing out of the ordinary, and our water sensor would alert us if there's ever a water problem in this low area so that we can alert the homeowner and get out before any damage is done.